System grounding requirements first appeared in the National Electrical Code, or NEC, in 1928. Grounding in electrical systems is the intentional connection of a neutral conductor or equipment enclosure to the earth. This connection provides a low impedance path for fault currents, which helps to quickly trip over current protective devices like circuit breakers or fuses, minimizing the risk of electrical shock and fire hazards. Prior to the formal introduction of grounding requirements in the NEC, electrical systems often operated without a direct connection to ground. This ungrounded operation could lead to several issues. One major concern was the buildup of static electricity, which could discharge unexpectedly and cause damage to equipment or even ignite flammable materials. Another issue was the difficulty in detecting and clearing ground faults. Without a ground connection, a fault current might not be large enough to trip a circuit breaker, allowing the fault to persist and potentially escalate into a more serious hazard. The 1928 NEC marked a significant step forward in electrical safety by formally recognizing the importance of system grounding. The specific requirements outlined in the 1928 NEC were less comprehensive than those found in modern codes, but they established the fundamental principle of connecting electrical systems to ground. This initial introduction laid the groundwork for subsequent revisions and expansions of grounding requirements in later editions of the NEC. Over the years, the NEC has been updated and revised numerous times to address emerging technologies, new safety concerns, and lessons learned from real-world incidents. Each revision has brought refinements and additions to the grounding requirements, making electrical systems safer and more reliable. For example, later editions of the NEC introduce more specific rules for grounding different types of systems, such as alternating current or AC systems and direct current or DC systems. They also address issues such as electrode systems, grounding conductors, and bonding requirements. Today, the NEC contains extensive and detailed requirements for system grounding. These requirements cover a wide range of topics, including the selection and installation of grounding electrodes, the sizing of grounding conductors, the bonding of metal enclosures, and the protection of sensitive electronic equipment from ground noise. The NEC grounding requirements are designed to work in conjunction with other safety measures such as overcurrent protection and insulation to provide a comprehensive approach to electrical safety. By ensuring that electrical systems are properly grounded, the NEC helps to protect people and property from the hazards of electricity. Grounding is not simply about connecting a wire to the earth. It involves careful engineering and installation practices to ensure that the grounding system is effective and reliable. A well-designed grounding system will minimize the risk of electrical shock, reduce the potential for fire, and improve the overall performance of electrical equipment. The specific grounding requirements that apply to a particular installation will depend on several factors, including the type of system, the voltage level, and the location. It is essential to consult the latest edition of the NEC and to follow the recommendations of qualified electrical professionals when designing and installing grounding systems. The evolution of grounding requirements in the NEC reflects a continuous effort to improve electrical safety. From the initial introduction in 1928 to the complex and comprehensive rules of today, the NEC has played a vital role in protecting people and property from the hazards of electricity. Understanding the history and principles of system grounding is essential for anyone involved in the design, installation, or maintenance of electrical systems. It is the foundation upon which all electrical safety is built. The NEC specifies requirements for grounding electrode systems, which are used to connect the electrical system to the earth. Common grounding electrodes include metal underground water pipes, ground rings, and ground rods. The NEC also provides rules for the size and installation of grounding electrode conductors, which are used to connect the grounding electrode to the electrical system. Grounding electrode conductors must be sized appropriately to carry the maximum fault current that is likely to flow through the grounding system. Furthermore, the NEC addresses bonding, which is the process of connecting together all metal parts of an electrical system to create a low impedance path for fault currents. Bonding is essential for ensuring that all metal surfaces are at the same potential, which reduces the risk of electrical shock. The NEC specifies requirements for bonding various metal components such as metal conduits, metal enclosures, and metal water pipes. The NEC also contains requirements for equipment grounding, which is the process of connecting the metal enclosures of electrical equipment to the grounding system. Equipment grounding is essential for protecting people from electrical shock in the event of a fault. The NEC specifies requirements for equipment grounding conductors, which are used to connect the equipment enclosure to the grounding system. These conductors must be sized appropriately to carry the maximum fault current that is likely to flow through the equipment grounding system. Furthermore, the NEC provides requirements for grounding sensitive electronic equipment, such as computers and telecommunications equipment. Sensitive electronic equipment can be damaged by ground noise, which is unwanted electrical noise that can be present in the grounding system. The NEC specifies methods for reducing ground noise, such as the use of isolated ground receptacles and dedicated grounding conductors. The NEC grounding requirements are not static. They are constantly being updated and revised to reflect changes in technology and new safety concerns. It is essential to stay up to date on the latest edition of the NEC and to follow the recommendations of qualified electrical professionals when designing and installing grounding systems. The proper implementation of grounding techniques is critical for the safe and reliable operation of electrical systems. It protects individuals from electric shock, minimizes the risk of fire, and safeguards equipment from damage due to faults. Firstly, grounding provides a low impedance path for fault currents, allowing overcurrent protection devices to quickly trip and energize the circuit. Secondly, it helps to stabilize voltage levels, reducing the impact of voltage surges and transient voltages. Thirdly, it minimizes electrical noise, improving the performance of sensitive electronic equipment. Grounding is a fundamental aspect of electrical safety and should not be overlooked. It is essential to follow the NEC grounding requirements and to consult with qualified electrical professionals to ensure that electrical systems are properly grounded. The importance of grounding in electrical systems cannot be overstated. A properly designed and installed grounding system is essential for protecting people and property from the hazards of electricity. By following the NEC grounding requirements and working with qualified electrical professionals, it is possible to create electrical systems that are safe, reliable, and efficient. The NEC also addresses specific grounding requirements for different types of systems, such as separately derived systems and high-impedance grounded systems. Separately derived systems are electrical systems that are not directly connected to the main electrical service. Examples of separately derived systems include generators and transformers. The NEC specifies requirements for grounding separately derived systems to ensure that they are properly protected from faults. High-impedance grounded systems are electrical systems that use a resistor to limit the amount of fault current that can flow through the grounding system. High-impedance grounded systems are often used in industrial applications where it is important to minimize the risk of arc flash. The NEC specifies requirements for high-impedance grounded systems to ensure that they are properly designed and installed. The NEC also provides guidance on the selection of appropriate grounding electrodes. Grounding electrodes must be made of materials that are resistant to corrosion and must be installed in a location where they will provide a good connection to the earth. The NEC specifies minimum requirements for the size and depth of grounding electrodes. In addition to the NEC, there are other standards and guidelines that provide information on grounding practices. These standards and guidelines can be helpful in designing and installing grounding systems for specific applications. For example, the Institute of Electrical and Electronics Engineers, or IEE, publishes standards on grounding for industrial and commercial power systems. These standards provide detailed guidance on the design, installation, and testing of grounding systems. The proper grounding of electrical systems is not only a matter of safety, it is also a matter of code compliance. Electrical inspectors will typically check the grounding system during inspections to ensure that it meets the requirements of the NEC. Failure to comply with the NEC grounding requirements can result in fines and other penalties. It is important to understand that grounding is not a one-size-fits-all solution. The specific grounding requirements that apply to a particular installation will depend on several factors, including the type of system, the voltage level, the location, and the local codes. It is essential to consult the latest edition of the NEC and to work with qualified electrical professionals to ensure that electrical systems are properly grounded. In summary, the system grounding requirements in the NEC play a crucial role in ensuring the safety and reliability of electrical systems. The introduction of these requirements in 1928 marked a significant milestone in the history of electrical safety. The NEC grounding requirements have evolved over time to address new technologies and safety concerns. By following the NEC grounding requirements and working with qualified electrical professionals, it is possible to create electrical systems that are safe, reliable, and efficient. Grounding is a critical aspect of electrical safety that should never be overlooked. The NEC serves as a cornerstone for electrical installations. It began in 1897, evolving into the comprehensive code it is today. The 1928 edition was a critical point in the NEC development, setting the stage for future advancements in electrical safety. This was around the time electricity was rapidly expanding into homes and businesses, making standardization and safety crucial. Prior to the 1928 NEC, electrical installations varied widely, leading to inconsistencies and potential hazards. The introduction of system grounding requirements in 1928 addressed many of these challenges, promoting a safer and more standardized approach to electrical work. In addition to system grounding, the 1928 NEC covered a wide range of other electrical topics, including wiring methods, overcurrent protection, and equipment installation. The NEC is a living document constantly updated to reflect advancements in technology and address emerging safety concerns. The NEC is not law itself, but it is widely adopted by states and municipalities, making it a legal requirement in many jurisdictions. Understanding the NEC grounding requirements is essential for electricians, engineers, and anyone involved in the design, installation, or maintenance of electrical systems. The NEC is available for purchase from the National Fire Protection Association or NFPA and other sources. Many jurisdictions also offer access to the NEC online. The NEC is not the only standard that addresses electrical safety. Other organizations, such as the Institute of Electrical and Electronics Engineers or IEE and the International Electrotechnical Commission or IC, also publish standards on electrical safety. These standards can be helpful in designing and installing electrical systems for specific applications. However, the NEC is the primary standard for electrical installations in the United States. Proper grounding helps to limit the voltage on equipment enclosures, reducing the risk of electric shock. Grounding also provides a path for fault current to flow back to the source, allowing overcurrent protection devices to operate. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of a fault. By providing a low impedance path for fault current, grounding helps to ensure that these devices operate quickly and effectively. Effective grounding contributes to the reliability and longevity of electrical equipment. Poor grounding can lead to voltage fluctuations, noise, and other problems that can damage sensitive electronic equipment. Proper grounding can help to mitigate these problems and improve the overall performance of electrical systems. The NEC specifies different grounding requirements for different types of systems. For example, the grounding requirements for a residential electrical system are different than the grounding requirements for an industrial electrical system. The NEC also specifies different grounding requirements for different voltage levels. The grounding requirements for a 120-volt system are different than the grounding requirements for a 480-volt system. It is important to understand the specific grounding requirements that apply to each type of system and voltage level. There are several different types of grounding electrodes that can be used to connect the electrical system to the earth. Common grounding electrodes include metal underground water pipes, ground rings, ground rods, and concrete encased electrodes. The NEC specifies the requirements for each type of grounding electrode. The selection of the appropriate grounding electrode will depend on several factors, including the soil conditions, the available space, and the local codes. Proper grounding of electrical systems is essential for protecting people and property from the hazards of electricity. The NEC grounding requirements have evolved over time to address new technologies and safety concerns. By following the NEC grounding requirements and working with qualified electrical professionals, it is possible to create electrical systems that are safe, reliable, and efficient. Grounding is a critical aspect of electrical safety that should never be overlooked.